Okay, now let us go through an example for the impulse invariant method. Okay, this is the question. Here, the transfer function for an analog filter that is given h of s is equal to 2 divided by s plus 1 into s plus 2. Now we have to determine the equivalent digital transfer function of IIR filter using impulse invariant method. Here it is given that t is equal to 1 second. So now let us start the solution. First, let us rewrite the analog transfer function given, that is equal to, here we have multiple poles, that means two poles in the denominator. S plus 1 into s plus 2 means one pole is at s equal to, one pole is s equal to minus 1 and another pole is s equal to at s equal to minus 2. Now we have two poles. As we have multiple poles, we have to express, we have to split this equation. That is the first step of impulse invariant method. Use partial fraction for that purpose. Okay, before that, let us put it as equation number 1, and by partial fraction now we are going to split the RHS of this equation. S plus 1 into s plus 2. By applying partial fraction method, let us write it as a divided by s plus 1 plus b divided by the second pole s plus 2. Okay, now let us mark it as equation number 2. And how can we find the values of a and b? Just multiply the denominator of LHS here and the RHS also. That is, multiply both the left hand side and the entire RHS by the denominator of LHS. Denominator of LHS means s plus 2 into s plus 1. Okay, now let's do that. Here we have 2 divided by s plus 1 into s plus 2. Now multiply with the denominator s plus 1 into s plus 2 here, which is equal to, in the RHS, a divided by s plus 1 into, again multiply with the denominator of LHS, s plus 1 into s plus 2, then plus b divided by s plus 2 into the denominator of LHS, s plus 1 into s plus 2. Okay, right. Now let us cancel some terms. Here both will be cancelled. Now the remaining is 2 equal to a. Here s plus 1 and s plus 1 can be cancelled. So here we have a into s plus 2 plus b into, here s plus 2 and s plus 2 will be cancelled. Okay, now let us mark it as equation number 3. Now let us substitute s equal to minus 1 in equation 3. Okay, s equal to minus 1. We have to substitute s equal to minus 1 and s equal to minus 2 in this equation in order to find the values of a and b. Now let us substitute s equal to minus 1 first. Then what we are getting is 2 equal to a into, now s equal to minus 1. Replace s with minus 1 now. Plus b into, again s equal to minus 1 plus 1. Now this one equal to 2 equal to a into, what is minus 1 plus 2, that is equal to what? Plus b into, what is minus 1 plus 1 equal to 0. Now the value of a we are getting is a equal to 2. Now let us put it as equation number 4. Now substitute s equal to s plus 2 equal to 0, then s equal to minus 2 in equation number 3. Then we will be getting 2 equal to a into 4s we are going to write minus 2. Minus 2 plus 2, then plus b into again is equal to minus 2. Minus 2 plus 1. Okay, here we have 2 equal to a into plus 2 plus minus 2 plus 2 becomes 0, plus b into minus 2 plus 1 become minus 1. Now the value of b we are getting is minus 2. Let us mark it as equation number 5. Let us substitute the values of equation 4 and 5 into equation 2. This is equation 2. Then we will get 2 divided by s plus 1 into s plus 2. Okay, that is equal to, in place of a, we can write the value of a, that is 2, and plus the value of b obtained is minus 2. Now let us substitute for b also. Now we are getting the answer like this. Okay, that is but then now what about this time? 2 divided by s plus 1 into s plus 2, that is equal to h of s. 2 divided by s plus 1 into s plus 2 is equal to h of s. Now let us replace the LHS with the h of s. That is h of s is equal to 2 divided by s plus 1 plus into minus become minus 2 divided by s plus 2. Now let us express this in standard form. The RHS of this above equation can be again rearranged as s minus minus 1. Okay, then that will be equal to minus into minus become positive, then that will be equal to plus 1. Then minus s minus minus 2 also. Let us mark it as equation number 6. Okay. Now in the design steps of impulse invariant method, we found that the analog transfer function h of s, that has to be expressed as the sum of single pole functions. Okay. So we formula to express the analog transfer function as the sum of single pole functions, where n is the number of poles. In our case, we have 2 poles, one at s equal to minus 1 and another at s equal to minus 2. So n is equal to 2 in this case. So let us rewrite this equation as k equal to 1 to 2 ck divided by s minus pk. Okay, right. Now let us expand the summation. For k equal to 1, we have c1 divided by s minus p1. Okay, right. Then plus, for k equal to 2, we have c2 divided by s minus p2. That is h of s. Now let us mark it as equation number 7. Now let us compare equation 6 and 7. Then what we can conclude. Here h of s, LHS are equal, then RHS should be equal. Here we can say that C1 is equal to 2. Okay. Okay, now we have C1 is equal to 2. C1 is equal to 2. Then what about the value of P1? P1 is equal to minus 1. Okay. P1 equal to minus 1. Then what about the value of C2? C2 is equal to, if we express this as plus, this one should be minus. So C2 is equal to minus 2, and finally P2 is equal to the value of P2 is equal to minus 2. Okay, right. When according to the impulse invariant transformation, any analog signal of this form can be transformed into corresponding digital transfer function using this formula. Okay, let us consider this formula. Then we have number of poles in this case is equal to 2, so n is equal to 2, so k equal to 1 to 2 ck divided by 1 minus e raised to pk t into z inverse. So now let us expand this equation. For k equal to 1, we will have c1 divided by 1 minus e raised to p1 t into z inverse, plus for k is equal to 2, we have c2 divided by 1 minus e raised to p2 t into z inverse. Okay, that is h of z corresponding to the analog filter h of s. Now let us substitute the values of c1, c2, p1, p2 from here. Okay, on substituting the values of c1, c2, p1 and p2, we will be getting h of z is equal to c1 is equal to 2 divided by 1 minus e raised to what is p1 obtained is equal to minus 1 into t. Okay, z inverse, then plus what is the value of c2 obtained, that is equal to minus 2 divided by 1 minus e raised to what is about p2 is equal to minus 2, so minus 2 into t z inverse. Okay, on rearranging we will be getting h of z is equal to 2 divided by 1 minus e raised to minus t into z inverse, plus into minus become minus 2 divided by 1 minus e raised to minus 2 t into z inverse. And now it is given in the question that t is equal to 1. That was given in our question. Okay, right? So let us substitute the value of t also. Then we will be getting h of z is equal to 2 divided by 1 minus e raised to minus 1 e z raised to minus 1 minus 2 divided by 1 minus e raised to minus 2 into t is equal to 1 here also. So this will be the equivalent transfer function of the digital filter. Okay, that's all about this transformation. Thank you for watching.